Welcome to the Early Career Professionals in Mapping webinar series. The American Geosciences Institute has partnered with the National Cooperative Geologic Mapping Program to highlight the work of early career geoscience professionals, especially as it relates to the use and production of geologic maps. Each webinar will begin with a presentation from an early career professional, followed by an interview and then a live Q&A session with the speaker. We are excited to introduce today's speaker, Carla Eichler. Carla grew up in Illinois and completed her undergraduate degree at the University of Arizona. She earned her doctorate in 2020 from Texas Tech University and is now a field geologist for the Oklahoma Geological Survey. She is here with us today to share projects in which she is updating geologic maps across Oklahoma.
Hello, my name is Carla Eichler, and during this presentation, I'm going to talk a bit about my job as a field geologist at the Oklahoma Geological Survey. A large portion of what I do is make geologic maps. I have mapping projects that span from the Ouachitas in the east to the Wichitas in the west, and I'm so excited to show you about what I do. Each survey and field mapper has their own approach to mapping. I'd like to share with you what I do here at the OGS. I have two seasons, the first being field season during the cooler months from October to March. During this time, I'm in the field in a truck, number 513 is shown on this slide, driving up and down county roads in the quadrangles I am mapping, looking for outcrop. If there's inclement weather, I'll return to the office and perform office-based tasks, like what I do during office season. Office season lasts from April to September when there's tornadoes or more heat and storms. I'll pencil and ink in the contacts in my quadrangles, work with the GIS team to digitize and format the maps to USGS standard. I'll read papers to ensure that I'm up to date on the geology in the area that we're mapping and look at other maps. I also travel to conferences and symposia to present my research and our maps. Some projects require me to prep samples for geochemical work, so I'll do that during this time. And I'll perform tasks and responsibilities that are not related to mapping that the OGS requires, such as public outreach, leading field trips for the public, and serving on committees at the university. I work in the office at Sarkees Energy Center, which we could see here is this big tower. At the moment, I work on two project teams, StateMap and EarthMRI. Both are funded by the U.S. Geological Survey. StateMap is my primary project, so I'll talk about it the most during today's webinar. In the StateMap project, we are producing a statewide geologic map at the 1 to 24,000 scale. So this is really detailed for a statewide map. This map can be used by the public or private companies or professors and their students to better understand what rocks are present at any given location. For the public and private companies, this could help them identify resources such as sand or limestone for gravel, hazards such as faults or soft rock that would not be safe for foundations or roads or buildings. And then in the EarthMRI project, we are producing 7 detailed geologic maps of the granites in the Wichita Mountains area. We'll produce these maps based on mineralogy to identify areas that may contain critical minerals. Critical minerals are elements that we need in order to make things like electric car batteries, copper wiring, metal alloys like stainless steel. I'm going to talk again the most about StateMap, and that's what these maps that I'm going to show you are based on. So just to make sure that we're all on the same page and what I'm about to show you will make sense, I'm briefly going to go over how to read a topographic map. A topographic map is more or less a 3D representation of a surface on a 2D plane. So these lines of elevation right here are above sea level. So this line that I'm highlighting is labeled 800. That's 800 feet above sea level. And then the lines between have a certain contour interval. So in this map, it's 20 feet. So this map below 800 is at 780 feet. The line above is at 820 feet. So we can read these lines based on their relationship to one another. So when they're stacked really close and tight on top of one another, like right here, that's forming a cliff. If they're far apart, that means that there's a flat surface or a flatter surface like a plane. So we can see that that's right here. We can also use labeled features on these topo maps to identify where we are. And we have 2 quarries right here. We can see these little hammers. Those are 2 quarries. This candy striped feature right here is a road, a major road. These dashed lines are probably gravel roads or something like that. And then blue areas have water in them, so ponds or lakes or rivers. And then these like black dots are buildings and houses. So we can use these all to help us locate where we are. So we have two maps on this slide. The first is a topographic map. The other is a geologic map. We use the topographic maps to make geologic maps. So we can see that on this topographic map, we have our contour intervals and our lines of elevation and things that I introduced on the last slide. I'd like to point out here the Pensacola Dam right here next to Disney, Oklahoma and Langley, Oklahoma. We are going to visit this area right here to show you how I take notes in the field, how I identify rocks, because this entire area, this lavender color, is the Boone Group, and that's a type of rock. And so we're going to go take a look at the Boone Group and see how I identify it and how I can come up with something that looks just like this.
We are south of the Pensacola Dam near Disney, Oklahoma, and we are sitting on the Keokuk limestone. So this entire unit that you see here is the Keokuk. I am going to show you how I identify this in the field and how I take notes on the different units. So here I am sitting on the Keokuk. We have two facies here. So the first facies is that of the limestone, and we can see this limestone is dark gray and karsted. That's what makes these little features right here that I'm pointing to. And then sitting on top of that is a bed of chert, and this chert is lighter colored and it's highly fractured, so you can see the fractures running through. They look very different from one another. So I make note of each of these units in my notebook, which you can see right here. I make a note about the outcrop itself, and then the different facies themselves. And then I take a GPS waypoint, and I take the elevation and the coordinates. Here is an example of my GPS, and we see the Pensacola Dam right here and where we are sitting. So I take all of this so I have a record of what is going on today. I make a note of the weather and anything that'll help me remember the day, and then I mark it on the map. So we are not going to do the map in the field because it's kind of windy out here. So I'm going to do that in the truck so we have better visuals and better quality of audio. So we are in the truck and there's Pensacola Dam. Here's an image of my notes so we can see that. And here is the map that I brought with us. We map on paper maps. This is our topo map. There's Disney. There's the Pensacola Dam right here. And you can see I located us and put there, that's stop number 1. That X is where we were. And I labeled it Mississippian Boone Group because that's what the Keokuk is part of. It's part of the Boone Group. And now you can see I also marked right here along the dam is also the Boone Group. So my notes correspond to that number 1, and then my map will show that we were located on the Boone Group, and that's what I saw along the dam.
So now that you've seen how I identify rocks and take notes in the field, let's take a look at this map again. So we can see our topographic map and the area we just visited right here. And we can see those areas that I have outcrop. We also have outcrop down here. So we fill in this area with the rest of the Boone Group based on papers that we read, other maps, research that has been conducted in this area that says the Boone Group is there, although it is not exposed. So we fill this in with an interpretation throughout this entire area. Now I'm going to show you other outcrops, not in this quadrangle right here, but further to the south and towards the east. In the Spavinaw quadrangle, we're going to look at the Cotter Formation. And in the Fort Gibson Dam quadrangle, we're going to look at how I map a vertical section.
So I thought I'd show a more typical outcrop that we see here in Oklahoma and that we deal with on a day-to-day basis. So we are in Spavinaw State Park, and it's a beautiful day, as you can see, sunny. I made note of that in my notebook. And these little mounds poking out of the earth are outcrops of the Cotter Formation, which is an Ordovician dolomite. So I made note in my notebook that it is gray to tannish in color, fractured, and these outcrops are 2 to 3 meters. And I made note of the GPS location and the elevation. So I'm going to go back into the truck and mark this on my topo map. So we are back in the truck, and as you can see on my topo map, I've located us. We're right here adjacent to this highway and the creek bed over there that we can see right there. So I put stop number 2, labeled it OCT, and then I put that in my notebook. You can see stop number 2. And I wanted to show you the finished map so we can see that the Cotter actually forms a large portion of this map underneath the city of Spavinaw. So again, we have our mark here, that's where we are, and that's the Cotter group.
Over these next few slides, I'm going to show you how I map a vertical section starting at the base of the ravine right here and moving our way up this road. And so this way you'll be able to see how I draw in contacts and make interpretations in the field.
So we have driven up the road a little bit until we crossed into the sandy unit that you can see right in front of us here in the wash, those big beds. I do believe that those are the Bloyd Hail. And so we put our contact between these units and just down the road. If you notice on the road, there is a hump from right about there all the way up to where I'm standing. That's probably the transition between the sandstone and the shale down below. So back at the truck, I've located us on the GPS. You can see right there where we are. I walked down just a little bit right by the D in road. And so I found us on here as well. You can see right where I'm pointing. I think that is the contact between the Fayetteville and the Bloyd Hail. We can actually see what I was talking about on the road, where we get this transition where our topo lines become more spread out over here and they are tighter together down over here. So we observe what we see on the map. That's great. So we've traveled up the road just a little bit more until we got to this outcrop. It is also a sandstone, but you may notice that it's a little more rounded and not as bulky and fractured as the last ones. This is because we've changed it into another unit that's not as cemented as the last one. It's a little more friable, medium grained. This is the Atoka, and so this is where our contact is, right below here, right about right here. I would put that contact between the Bloyd Hail and Atoka. I've hiked back to the truck from the contact between the Bloyd Hail and the Atoka. So we are hiking up this right here. And I've put the line right about there based on our GPS and the topo lines themselves. Again, we see that the topo lines are telling the story, where these are even further spread out based on how that sandstone is weathering versus the other sandstone. So with that, I know that the rest of this is all Atoka, all the way up to where this cluster of houses are. And I think we're done with this section.
So after field season is over and I'm back in the office, I begin to pencil and ink the maps. I will lay out my maps on a big table. I have about 8 maps that I'm working on at a time. And I'll look at the areas where we saw outcrop across all of these quadrangles and begin to draw in the contacts between the outcrops. So I will start on one map where we have solid information and start to pencil it across and look at where the other contacts are across the entire area. So I'm making an interpretation across 8 maps. So that's why I use pencil first, just in case some of the interpretations don't really make sense in one map as opposed to another. But once that I get to a point where all of my penciled contacts make sense with one another, I'll ink them in so that way we could better see them, and it's more of a permanent record for us. We'll scan these in to a computer and digitize them with the GIS team's help, of course, and then we'll format them to the mapping standards required by the U.S. Geological Survey and submit them to the USGS. So to bring this full circle, let's look at the Spavinaw quadrangle. So this map should look really familiar by this point. This is our Spavinaw quadrangle. And so here's our topographic map that we started out with, and here's the final geologic map. Hopefully now it makes a little more sense on how we got from this to this and drew in these very specific contacts. And I promise you, it takes a lot of work to go through this entire area, but it's well worth it to make sure that the citizens of our state know what resources are available and where the potential hazards lie. I thank each and every one of you for your time and attention and allowing me to share my job and my passion with you.
Great, Carla. Thank you so much for sharing some of your work that you do with Oklahoma Geological Survey. Lindsay and I are excited to dive into some of the details of your work and hear about your experiences leading you to a career in geologic mapping. But I know you have a guest with you. Do you want to first introduce your guest that's behind the camera?
This is Poe. She's my little office assistant. She's a very good girl.
We're glad to have Poe joining us today.
Yeah.
And you spoke briefly about this during your presentation, but will you first provide us a brief description of how geologic maps are used and also the importance of producing up-to-date geologic maps?
Sure. So the maps are typically used by the public and academics to know where the rocks are, like what types of rocks are in which location. So if someone is looking for, say, to drill a water well, they can find where that aquifer is, where it's expressed at the surface and how it dips underneath the earth. So they can better estimate where to drill their well, because you don't want to keep drilling forever. It's very expensive. And likewise with people who want to sample rocks, so like academics who want to go out and study these rocks and they need to go grab a sample really quick, they can look at our maps and go out and sample these rocks. And so, yeah, that's one of the uses. I think we also, update these maps based on the need. So, like I kind of mentioned in the presentation that we're growing here in Oklahoma. The OKC area is growing, the Tulsa area is growing, and new subdivisions and buildings are being built, and infrastructure is being built, like bridges. We need to know where the safest places are to build buildings and put these large corporations and things of that nature. So it's really important to have up-to-date maps, and the maps that we had prior to state map were from 1954. So they're at a larger contour interval. Oh, sorry. They're at a larger scale, and so it's harder to know in detail where to put these infrastructures and buildings and things like that. So, yeah.
Awesome. And then how often, so you mentioned like the importance of updating, how often are they updated? Because you mentioned the maps were from 1954. So
yes, yeah.
Is common, or how?
I mean, I don't know prior to that when they were previously mapped, if that's, if it was like 1920, it wouldn't surprise me. But I do believe it's on the decades, these maps are really expensive, to make. And so they need a lot of support, and we need, at the survey level, we need the state and the federal governments to, support this, because it's very, very hard to do this for very cheap. So whenever we can get the funding, that's when we do it. And the State Map Initiative is pretty recent, really recent initiative. So without it, I don't think we would be doing these things. So yeah, I would say decades.
And that was my next question for you, was what kind of prompts these updates? So is it really the State Map Initiative for the specific map that you're working on, or the maps that you were showing in your presentation?
Yes, yeah, all of those are state maps, and it's truly, the USGS is the one that requested these, because, like I mentioned, they want a geologic map for the United States, which is such an undertaking. And I know another part of this initiative that I didn't go into in the presentation is they want to make a 3D map, so subsurface, and project these all underneath the United States and see, what the basins look like. I kind of mentioned some of the basins, and they want to see where the mountains are and things of that nature. So this is a really big undertaking, and so it's mainly the USGS who's requesting us to do all this work, boots on the ground, so to speak.
So big undertaking takes a big lift of effort. How did you become qualified, and your experiences leading up to being able to read and make the maps that you displayed in the video and that you do every day for your job?
Oh gosh. It really went back to my undergrad. I went to the University of Arizona for my undergrad, and it's a very field-based school. So that first course, freshman year first course, I'm out in the field. And it was intimidating. I'll be honest. But with enough time and enough experience, it became just normal. It's like, I would look at the syllabus and be like, okay, where are our field trips going? Where are we going? So, and I got the privilege of being able to teach people how to map. So during my master's and during my PhD, I got to teach people how to map, and there's no experience like teaching people. That's when you really get to learn it yourself. So that really prepared me. That was the number one thing that led to this career. I did receive some on-the-job mentorship, but it was more of getting used to how the OGS runs, not on how to map. Like that was kind of expected to come in knowing how to map. But yeah, like that was most of my experience was being in class and getting graded on my maps.
In conjunction with that, you mentioned this briefly. Can you speak to your experiences leading up in terms of academics? You mentioned master's and PhD. Can you kind of lead us through your trajectory that
Sure.
led you here?
Yeah, so yeah, I mentioned the University of Arizona. So after that, I went to the University of Nevada, Las Vegas. So lots of field areas around there. It is gorgeous. So yeah, I did a lot of teaching in that area. We went to the Valley of Fire, and then Red Rocks and all of that. I didn't do a lot of mapping for my thesis in particular. I actually used maps in that case, so got that kind of user experience, so to speak. And then during my PhD, again, I didn't do a lot of mapping for the dissertation itself, but I did use, maps and I guess stratigraphic intervals, so looking at the rocks vertically rather than horizontally. So kind of like what I showed in the presentation where we were going up section, I did things like that. So again, very user-based, but yeah, teaching it was really where that skill became very honed in. And I got to teach field camp, which when you're a geology major, that's like the culmination of everything coming together. And a lot of mapping was done there. So yes.
So, if your schooling was in all around the country in different areas, how familiar were you with the geologic units in Oklahoma before starting working there?
Not very. I mean, um, I worked for a little bit in between my master's and my PhD, and I actually worked here in Oklahoma for Halliburton, and I was making big basin models. So I had an idea of the names and the ages and thicknesses, but aside from that, I wouldn't be able to recognize them in the field. I was behind a computer the whole time. So coming back to Oklahoma, I knew the names, but now I kind of had to put a face with the name, so to speak, for these rocks. So like going out in the field and recognizing the Boone Group was a new experience. So yeah, it was learning. It was a learning curve right there.
Yeah. And similarly, you're talking about how they want to make a geologic map for the whole country. So how is it that you work with surrounding states to maybe map some layers that cross over the boundaries of those states?
Oh, yeah, that's a great question. So we actually work pretty closely with the Kansas Geological Survey. Their geology is very similar to ours because our basins continue northward into Kansas. And likewise, with Iowa, Nebraska, Missouri, a lot of our geologic systems are the same. We're working with the same rocks. So geologists like to change names at state borders. It doesn't make sense, so one unit will be called something in one state and another. So we are actually working closely with the Kansas Geological Survey to make sure that these names, are continuous throughout the section. And so that's actually part of our state map for this next year, is we're mapping right along that Kansas border to see if we can map the same units that they can, because a lot of our correlations are subsurface. So they express themselves in Oklahoma, but they were mapped subsurface in Kansas. So we're working closely with them, and I'm looking forward to continuing this work throughout the next year.
Great. So you talked in your presentation a little bit about some of the units that you find in Oklahoma. So can you tell us a little bit more about Oklahoma's history and the formation of some of those units?
Sure, yeah. So it's actually really interesting here. I mean, I know people think, I used to think Oklahoma flat and boring, but we actually have a lot of smaller features. Oklahoma's geology is very old. So like the rocks that we were seeing at the surface that we were mapping, as a group, they're 300 million years old, 350 million years old. That's old. And those mountains that I mentioned, the Ouachitas and the Wichitas, are also very old. They're part of the same system as the Appalachian Mountains. So, if you can imagine the Appalachians all the way through, Pennsylvania, all the way down here to Oklahoma, that's the same mountain chain. And it occurred when the two continents were, Laurentia and Gondwana, were colliding with each other. That happened ages ago, So some of these units are, deposited in a big basin in front of that mountain chain. That's something that I want to research and look into. How quickly were these sediments being shed off the mountain? And are there other sediments coming in from, say, Pennsylvania? There was a large river or something like that. So it's kind of complicated, but it's pretty straightforward when you get used to it. So I think in terms of deep time, 300 million years old is nothing. And I also like to think in terms of tectonics, which is just the way that the plates move and the earth moves, because we actually have a lot of earthquakes here in Oklahoma. We have it on our website that there are active earthquakes, and all of these faults are very old. They're not like the San Andreas, they're not new, they're very old and they're very deep in the crust. So we got to think, deep in time and deep in the crust. And so, yeah, and a similar thing with that is the Wichita Mountains that I also mentioned, but I don't really cover very much. They are part of a failed rift system. So like how we, think about Iceland and, the mid-Atlantic ridge, those ridges can actually form under continents and start to spread. And so we have one of those here in Oklahoma, and it's a failed rift. Obviously, we're not in the middle of an ocean, but so we have things like that where it's like, it's not obvious to, the average person because it's not active, but it's here. And so that's the kinds of things that we like to study here at the OGS.
Awesome. Can you speak a little bit more about the OGS and your experiences with specifically like Oklahoma Geological Survey?
Sure. So the OGS is rather small. We have about 24 or so personnel, and so in comparison to other surveys, that's pretty small. There are teams in other surveys that have 5, 6, 7 people mapping. I'm one of 2 field mappers, so this provides lots of opportunity, though, for me to wear many hats, get involved in different projects. We collaborate very well here, so that teamwork is very essential to my job. And I know, some surveys are more public service oriented, so they like to get involved with environmental services and things of that nature. We are more towards the idea of research and then putting that research and that data out for the public's use. So I guess mapping is kind of research. It's not hard data, but we're making it so that way people can use it, whereas others are more getting the public involved in their research. So in that way, I guess we're kind of unique, but I'm sure that there are other states out there who are also very research oriented and very small.
You compared the Oklahoma Geological Survey to other surveys. What about the mapping process? Because what you described in the videos, I don't know if that's, can you speak to if that's common through other surveys as well?
Yeah, so other surveys do approach things differently because their geology is very different, their climate's very different, and their teams, like I mentioned, are big so that people can be a little more focused. Since that we have such mild winters, we actually go out in the summer. Or in the winter. So, some places they go out in the summer, like I don't know if they could go out in Montana in the winter. Everything would be covered, So there's that difference in the seasonality. But I know some other surveys, they do like weekly blocks and they will go out for weeks and camp. We don't camp. We go to hotels. We have like a home base, and then as part of like my initiative with the state map is to get everything digital. So that way, when we go back to the hotel, I can upload my digital maps and have the GIS team start working on them. I know at other surveys, this might not be common, where they might actually just hand them data and say, here, make the map all at one time rather than uploading it in increments. I think this would be easier for our GIS team. So our process is a little different, but the overarching theme of how to map is pretty much the same.
Awesome.
So you mentioned people who would use geologic maps and some of the reasons why you do that, but have you found that there are some units that are considered more important than others, maybe because of what they contain? Do you have any examples?
Yeah, I do. So that black shale that we saw at the bottom of that ravine that we mapped, that's the Fayetteville. Well, I already told you that, but yeah, that's the Fayetteville, and that's actually an oil-producing unit, and it's called a source rock. So that's where the oil comes from. It's the source, and that's actually been a very popular unit in Oklahoma and Arkansas to drill into and frack, so we could get the leftover hydrocarbons to, escape and be used for fuel. So that's a unit, for example, that people might want to actually go out and put hands on rock and see, and see how the layering is and how can we break this rock better? That's kind of a common question in the oil industry. But yeah, there's other units like the Garber sandstone here in central Oklahoma is actually an aquifer. So we want to know how that aquifer recharges. So when it rains on the Garber, it actually starts percolating down into the aquifer. And so we need to know where that is. And so the geologic maps will help with that.
And then in addition to your state map project with mapping, you also mentioned at the beginning of your talk about your project with Earth MRI pretty briefly. Can you speak a little bit more about the project?
Sure. So the Earth MRI project it's separate from state map and all that. That's why I didn't really cover it, and we're just starting it. So I don't have a whole lot of detailed maps to show, and that's one of the reasons I didn't cover it. But we're starting it this fall. So we are looking at the granites in that area. They've already been mapped under state map, so we have that reconnaissance level map. So we're going into, for example, the Lugert granite, and we're going to be looking at the mineralogy within that entire granite body. And because granites are not always homogeneous, contrary to popular belief. and so we're going to be looking at different units within there, the mineralogical units, and trying to determine what minerals are in there. So we already went out briefly this spring before it got super hot and sampled some of the units. So we have an X-ray fluorescence gun. So we are using it to get an idea of the general mineralogy just from these samples that we, grabbed, like saw the unit, grabbed it, and took it back to the lab, and that's where they are. So we just got the XRF, and we're being trained on it. So that's kind of part of it, but the mapping part hasn't even begun yet. And so we have, I believe, 7 quadrangles that we are required to map, and then the rest of the area is we're just going to sample the sediments and not map them because they're pretty continuous throughout the area.
And is that pretty typical that mappers are doing basically collecting data to figure out the mineralogy of the rocks, or is that unique in your situation or for the OGS?
Yeah, I think that's more of the OGS being a smaller team. Again, I have to wear many hats. I'm not a petrologist, so I do not know much about these different rocks that we sampled, the granites. But the person who is the principal investigator on this is a igneous petrologist, so she'll know more. But yeah, I had to do that for this project just to get the ball rolling.
So let's talk about maybe just your career pathway to kind of get into geoscience. And you mentioned this a little bit with your schooling, but maybe talk a little bit about how you became interested in working in geoscience in general, and then maybe just some of your favorite parts of being a geoscientist.
Sure. So I was I grew up on a farm. So I'm from rural Illinois. So I was always outside. So it kind of fit. We were never a camping family or one of those, outdoorsy types, but I was always outside. So it kind of made sense to me to go into something in the natural sciences. And it was honing that was the hard part. Like I wanted to be an entomologist for a while and a biologist. And then in 8th grade, in Illinois, we were required to take an earth science class. And I just like fell head over heels for rocks. I don't know what it was. Maybe it was the enthusiasm of my teacher or something, but it clicked, and I was like, every rock has a story. This is incredible. And that's when, I started collecting rocks and going to rock shows and, all of that. So I would say it began in 8th grade, really. And I decided that I wanted to be a geologist. And so I was a student in Upward Bound, which is a TRIO program. I'm a first generation college student, so it's geared towards, potential first generation college students. And since there were no geologists in my very rural community for me to shadow and learn from, they had me take a community college class at our local community college. And it was a geology field-based class. So I went to Montana as a senior in high school and got to dig up fossil leaves in the Hell Creek Formation, which was an amazing experience. And so I guess that maybe is one of the first field experiences I can honestly say that I've had as a geologist, and it was profound, and I loved it. So yeah, I think that's kind of where it all settled in, and I decided I wanted to be a geologist. And the best my guidance counselor at my high school could give me was a list of geology colleges, and I picked Arizona. I'm like, that's the one. So I went from there, and then kind of honed in on my specialty and what I wanted to study in those classes. And yeah, so it really did begin when I was a kid.
Can imagine Illinois. I'm from Illinois as well, so Illinois to Arizona is always nice change, nice weather, different part of the country.
Really good food.
So it's awesome that you really got involved in the geosciences from such a young age, but like, what are some of your best experiences, like things that are keeping you in the geosciences?
Oh yeah, that's a great question. So I obviously really like the field. So, every time I get to go out in the field, it like waters the garden, so to speak, where it's just like, oh, I feel refreshed and replenished. And, it's kind of just part of, I guess, connecting with the earth that really fuels that. And it does get the curiosity bug going too, when I see a rock and I don't know what it is, or or I have a vague idea, and I want to know more about it. So that also fuels me staying within the geosciences and wanting to do more research and wanting to know that drive of curiosity. So I think that would be one of the main things that keeps me going.
Awesome. And then kind of forward thinking from there. So where do you see yourself kind of going from your position? Do you have aspirations to stay with OGS? Where in 20 years would you see yourself still out in the field looking at deer and looking at rocks?
I mean, I'm being, I guess, set up to take over State Map. My mentor is retiring. So, I have a vision of where I want that to go, because we do have, another maybe 10 years worth of work here in Oklahoma. We are slowly approaching the Ouachitas, and that's going to be a very ball of yarn to map. Very, very accordion-like geology there. So I do see myself working further in that. And then I wanted to also continue my more personal research. So I did my dissertation work on the Ogallala Aquifer in West Texas. It also, I guess, comes out into the Oklahoma Panhandle as well. So I want to continue studying that aquifer and that sedimentation. And I want to get off the floor idea of research in the Ouachitas and the Arkoma and Anadarko Basin, so that, that basin front going through Oklahoma. I want to look at those sediments a little bit more and get a better handle on what was going on with the Ouachitas, because at the moment we only have a few data points of, where was this rock, during this time. We don't know if it was here or here, so that's some of the things that I want to get going in the next 10 to 20 years or so.
Awesome. Well, it's great that you have those personal goals and you have some trajectory for the future that will keep you interested and keep you out in the field. That's awesome.
Yeah.
And I'm guessing that some people watching are also having those, professional goals, things that they're looking forward to in their career. So, do you have any advice that you could pass along to someone on work related to the geosciences?
Sure. I mean, if someone's, just beginning to think about it, like, an eighth grader, get started now, like, I mean, you can do things like join a rock club or go to rock shows or even just watching documentaries about volcanoes or something, getting interested and starting to build that knowledge base is so essential. And then if someone's like, more mid-career, getting out and meeting people at societal meetings, like the Geological Society of America or the American Geophysical Union, making those connections is absolutely essential, and getting to get to know people's other people's research, so that way you can complement one another. So yeah, that's kind of I guess part of the teamwork and in the societal part of the geosciences, because I imagine that a lot of people think we're just in the field alone, in the lab alone. Nah, you got to know people. You got to get out there and shake some hands. But I would say that that's part of it. And for people who want to do like industry jobs, getting to know, where are the trends going? Are we going more towards, petroleum production, or what's going on there? So just putting your finger on the pulse, so to speak, of what the industry is doing is also a really good way to get your career going.
Awesome. Well, amazing, Carla. Thank you so much for your time today. We're going to probably cut off here just so we can save some time for the audience to get their questions in. But again, thank you so much for talking with me, Lindsay, sharing your work and the advice that you've given and just the information you've shared today. We've really appreciated it.
Thank you.
We will now be moving into our discussion session where Carla can answer any questions that you might have. As a reminder, you can ask questions by typing them into the chat. But to get the discussion started, Carla, we were wondering, how much of Oklahoma have you traveled to?
Well, I guess that's a hard question to answer, but I've traveled to a decent amount, especially up in the Tulsa area, where that's the area that we've been mapping. So that Spavinaw quadrangle that we saw in Fort Gibson. I would say that area is well covered, driving up and down the county roads and things of that nature. But for the rest of it, I mean, I've driven through the Panhandle once, so it's just those areas that I've been mapping. So a fair amount up in the Northeast, I would say.
And so as you're doing that, what's the typical ratio of making observations versus interpretations while making your maps?
Yeah, that's a great question. I would say we lean more towards interpretation, especially in that area, in the Northeast area, where there's very large areas of, weathering shale and things of that nature. So like you're driving along and it's just flat because it's all shale, and it's very shallowly dipping. So I might mark a handful of points and then just, extrapolate between those, that we see this flatness in the shale just right, in here. So yeah, so a lot of interpretation right now. I think it's probably going to continue along that way as we move further south towards the Ouachitas. As the geology gets more complex, we might need more boots on the ground kind of looking at rocks, but at the moment it's a lot of interpretation.
Thanks, Carla. We'll probably get to some questions in the chat. Our first question from an audience member was, your description of your work makes it seem like you work alone most of the time. Is that true? And are there collaborations and or partnerships that help to enable your work?
Oh, that's such a great question. So, like in the field, we go out in pairs because of safety, and making sure that we're being safe, and if anything happens to the vehicle, we have at least 2 hands or 4 hands to help. So in that sense, I am making my maps with basically myself, But when we go back to the office, that's when the teamwork really does begin. And that I do have to coordinate very closely with the GIS team to make sure that, my maps are being represented, and that if they need to check with me and be like, all right, I see this here, is that a smudge or is that real? So things of that nature. We do have to work closely, and in Earth MRI, we're going to have to work with a large group of people. And that we're going to work closely with the USGS. So this is even from state to federal level. So that geochemistry work that we were doing is going to be sent to the USGS. So I guess in a way, I do have some independence, when I'm mapping, but the rest of it is a lot of teamwork and a lot of those communication skills and, group work skills that everyone is learning, hopefully right now.
Well, speaking of those communication skills and working together, there was a question in the chat about becoming an intern of yours. So can you speak to any opportunities that might exist at OGS, or how someone maybe goes about getting an internship?
So I don't think we have a formal internship program, but we do, if that person is at an Oklahoma school, we do work with EdMap. It's like State Map, but it's for education. And so we will work with that person and their advisor, or a chosen advisor at their university, and we will map a 7.5-minute quadrangle in detail with that person. So it's kind of like an internship, but if they are not at Oklahoma, I would suggest that they contact their state survey and see if an EdMap project is available for them, if they can work closely with that. Or I don't know if their state map team is big enough, maybe they could do a ride along. Like I mentioned, we go out in pairs. It can never hurt to have another set of eyes looking for rocks.
Awesome. Our next question in the chat was, how do you communicate information about the certainty of geologic interpretations? How do you communicate the density of your field points, such as how many points per square mile?
Oh, that's a great question. So I guess certainty wise, we don't have like error bars or anything like that. So it's I guess the same caution one would use with looking at any other map, or a set of data points that you don't have any quantitative data on. So I guess take it with a grain of salt is the best I can say. But to, I guess, kind of get back to that other part, let's see, I don't know how to phrase it. So we do have, those X's on the maps themselves. So ideally, if you went to that location, like on the Spavinaw Quadrangle, where we were south of the dam, there's multiple X's over there. So you could say that data density is pretty good in that area, whereas the rest of the lavender color kind of doesn't have too much to the north. That's all interpretation. So I guess that's the area where it is definitely the grain of salt. But ideally, if a person went out there and either dug a trench or something like that where there are no rocks available, you should eventually hit the Boone Group right below that soil line. So the X's are only where we have outcrop. Otherwise, the rest of it is, I guess, up to interpretation by other people too. So I hope that helps.
That's great. As you're doing that work, someone in the chat asked, have you tried digital mapping specifically with a tablet?
That's what we're switching to. That's a great question, because that's where I think a lot of field camps and I guess other training tools are being used. There's different programs like Field Move and Arc Field and StraboSpot. There's a lot of different programs, but I think once that a person gets used to one, it's straightforward. I guess the difficulty I'm facing is choosing which one to move to. But yes, we are going to be moving to digital mapping, and like I mentioned, it's going to be much easier for our GIS team. They've already expressed great interest in moving to digital mapping.
And another technology, drones. You want to talk a little bit about the work that you guys are doing with those?
Yes, we are really excited about our drone work. So we are in the process of selecting and going to be mapping with drones, especially as we get towards the Ouachitas. As I kind of mentioned and alluded to, it's, an accordion. You're going up and down these mountain ranges. That's going to take a lot of groundwork. So what we'd ideally do is approach that with LiDAR and drones and drone imagery to be able to kind of do some preliminary mapping and then go ground truth that by going in these areas where there are maybe less roads, and things of that nature. So we can really focus our efforts on specific areas to make sure that what we are interpreting from our LiDAR and from our drone is actually true. So it's going to be a different approach once we get down there. But yeah, we do have someone being certified as a drone operator, and we are in the process of picking out a really fancy drone to fly in these areas.
Great. Our next question from the chat is, I love rocks too. What is your favorite rock?
Oh, geez. I'm going to be really boring and say a conglomerate. I pick that because it can be made up of so many different types of rocks. Like you can get like rocks within rocks. It's like a one of those Russian nesting dolls. You can get rocks within rocks. So it's kind of a cheating question that I'm saying multiple rocks. But I like conglomerates, and again, it kind of goes back to my dissertation work of the Ogallala. It's conglomeratic in its base. And so that was the most difficult part of my dissertation, was identifying these different cobbles. And it could be anything that's in New Mexico ended up in Texas. So it was a challenge, but I would say a conglomerate.
I didn't see that one coming. So going back to the technology, someone asked, do you think technology is heading in a direction that will lead to a time when geologic maps are made without anyone going into the field?
Ooh, possibly. I that is a worry of mine, that I'm going to be put out of work. So I think it's, at the moment, we're safe. Mappers are safe in that we do need someone out there going out and verifying that what this drone or whatever is interpreting is actually there. Because at least in my lifetime, I don't think the technology is going to be there that it can absolutely do like geochemistry from the air and blast X-rays out of a drone to type these rocks. So I don't think we're in any danger, but I mean, anything can happen in the future. But in my lifetime, I don't think so.
Awesome. So one of the questions was, do you have any plans of working in any other countries, such as Africa, in the future? And I wonder if that's more for geologic mapping with the USGS or another program in general.
Yeah.
You, Carla, specifically, do you have any plans of going outside of Oklahoma to do some mapping?
Not really. We do have one, our state seismologist does work in Antarctica, so it's not unheard of, but usually the state surveys focus within their states. It's probably for our best interest as well, because dividing my time between my personal research and what I should be doing to serve the state, it could get tight. So no, I don't have any plans in working in Africa or any other country outside of Oklahoma, and maybe working into Kansas. Like I said, with the Kansas Geological Survey, we hold hands, we're nice to each other, and we'll work across that state border. So that's about as close as I'll get.
So I know you mentioned this in your talk, but someone asked, how often are maps published? We just want to reiterate how very little that happens.
Yes, like decades. I did eventually look up that map previous, and it was 1924. So it was almost exactly 30 years from one map version to another. And like people are pointing out, everyone's very much thinking about this as our technology is going to get better and better. And, in the future, we might have to update these maps because we don't have the geochemistry labeled on it or something along those lines. The detail can get even finer. So I would not be surprised if the end of my career, I'm making another statewide map or something along those lines. So it just depends. Yeah, again, if the government or the state needs a area mapped, that's when we go and map it.
Great. Thanks, Carla. And I think we have about time for 3 more questions. First of which is, are you attending the GSA conference this October in Pittsburgh? Or you can take that more broadly as, how do you normally share your work? Do you usually attend face-to-face conferences?
Yes. I will be at GSA. We have, my boss and I have a poster. So if you look up Nicholas Heyman and Carla Eichler, our posters on the energy transition in Oklahoma and how we're trying to lead that. It's very difficult, but Earth MRI is part of that, of trying to get that lithium out of brines and the granites so we can help make car batteries. So yes, I have a poster at GSA. Come swing by, I'll be there. But yes, I think it's absolutely essential that we go to regional, nationwide, and even down to state level conferences, symposia, whatever, to get this out, that we are doing a lot of great research here, not to brag, but and that we can help other states better understand their resources and how to extract them, and we can help hopefully lead the way and collaborate with these other states to get this done. And of course, the public, all of our information is public. Anyone can use it if they are so inclined.
That's great that you guys make that public. So speaking of, do you use any other sources to go along with the data that you're collecting and making your field maps?
So yeah, I will definitely use whatever is available, in the sense that, here at OU, people are publishing on the various units, all the time. I mean, there's so many master's theses coming out. And so one of the students that I served on her committee did research on the Garber. And so she described it in core and then went to the outcrops and described them as well. So we have this subsurface surface correlation. I obviously read her thesis, but that will become part of my mental record for if I ever come across the Garber and need to map the Garber. I will go back and use her thesis because it's a year old, as opposed to some of the other references which are decades old. So yes, we do use other resources, whether they are public or if we have to paywall. But unfortunately, that's part of science. But yes.
And then I think our last question that we're going to have time for is, the Ouachita Mountains are a fascinating range. Do you have any favorite mapping area in southeast Oklahoma?
That's a tricky one because I don't yet. I am actually going down to Beavers Bend, that area, and Broken Bow this Friday to work with some of my USGS colleagues. We're sampling ash tufts in the Stanley group. So at the moment, that's going to be my favorite one because that's the one I'm doing field work in, but I do not have one yet. But, in the next few years, who knows, that could change.
Great. And then just to follow up real quick to that are there any areas that you see that need more detailed mapping or investigations in areas that you've been, or is it kind of like mapped it, checked, come back to it in 50 years?
Basically. No, there's definitely that large swath of the central eastern portion all the way down through the south that we haven't touched. And actually my friend that my USGS colleague was like, do you have any 7.5-minute quadrangles for this area? And no, we don't. What you have is what we have. So there's dire need in that area specifically to get that those quadrangles out and published.
That's great. Thank you so much. We want to thank everyone for attending today, and we're sorry that we didn't get to a few questions in the chat, but if anyone has additional questions, you are able to email us at webinars@americangeosciences.org, and we can forward your questions along to Carla so you can get those answered. Within the next week or so, we'll be posting the recording on AGI's YouTube page as well as our webpage, and we'll also notify all attendees once the recording is available. Thank you again so much, Carla, for sharing your time and expertise and insight with us today. It was a great talk, and we are so glad that you were able to join us.
Thank you guys as well.
And then next up in our early career professionals and mapping webinar series is Valerie Harrison from the Tennessee Geologic Survey, who will be discussing applications of field techniques and technology in geologic mapping on October 3rd. A few more details about the talk and register using the link that will be soon to come in the chat. And if you are an early career professional in mapping or know someone who is, please encourage them to apply to be a speaker in this ongoing series. Applications will open in January for the next round of speakers. And thank you everyone for joining us today, and we look forward to seeing you next time.